Now let's look at the properties of the function y equals 1 over x. Now when we talk about the properties of a function, we're really talking about these 8 properties, right? Domain and range, continuity, etc. And the key to to figuring out the properties of y equals x is to memorize the graph of y equals x. So let's memorize that. You have y equals 1 over x. So the first thing we're going to do is, if you have y equals x, you're going to have a vertical asymptote at y equals 0. I'm going to go ahead and do the vertical asymptote in red. So you're going to have a vertical asymptote at x is equal to 0. And you're going to have a horizontal asymptote at x is equal to 0. That's going to be a horizontal asymptote. I made a mistake. The vertical asymptote is x equals 0. The horizontal asymptote is y equals 0. Now, usually you won't necessarily see that because they'll be on the xy lines, axes. But that's all right. We're going to draw it this way. Then what's going to happen is this in this quadrant here, the graph is going to look something like this. In fact, it's going to approach the vertical asymptote, and it's going to approach the horizontal asymptote. And to get a sense of scale, this point right here is going to be the point 1, 1. Then the graph is going to have a mirror image across the origin, say right here, and it's going to approach the vertical and horizontal asymptotes again. And this is going to be the point, this point right here is going to be the point minus 1, minus 1. And you could plug some other points if you want to. This is going to be the point 1/2, 2. This point here could be the point 4, 1/4. All right, give you a sense of scale of what these look like. But that's the basic idea of the graph. And once you memorize the basic idea of the graph, then the idea of the properties is going to be fairly straightforward. So here are the first 4 properties, and what I'm going to do is I'm going to just draw a very small sketch of the graph of y equals 1 over x. Here you have vertical asymptote and a horizontal asymptote, and it's going to look like this. So domain, so remember when we do domain, the key is what x cannot be, and here x cannot be 0. So it's going to be all real numbers. Let's write it in English first. It's all real numbers except x is not equal to 0. And the range is going to be the same thing. The range is going to be all real numbers except y can't be 0. And let's go ahead and write that in interval notation. If we would graph that, it would be something like that, right? Where this is 0, that's what x is. So domain is going to go from minus infinity to 0, and then it's going to go from 0 to infinity. And you put a union sign there, or you can put an and there if you want to. And the range is going to be the same, from minus infinity to 0, and from 0 to infinity. And that's the domain and range. Let's look at the next properties. So the next one is continuity. It's going to be discontinuous at x is equal to 0. And if you want to know what kind of discontinuity, it's going to be an infinite discontinuity. Now let's look at increasing and decreasing. Again, what does the graph look like? The graph looks like this and looks like this. If you notice, the graph is here it's decreasing, and there it's decreasing. So it's decreasing everywhere in the domain. So you can say that it's decreasing from minus infinity to 0, and it's decreasing from 0 to infinity. And right, because here it's decreasing and here it's decreasing. And now let's look at boundedness. This is an unbounded function. So those are the first four properties. Here's the domain and range. Here's the continuity. It's discontinuous at x equals 0. Here's the increasing and decreasing. It's decreasing across the domain, and it's unbounded. Let's look at the next four. The next four are extrema, symmetry, asymptotes, and end behavior. Extrema has to do with whether there are maxes and mins, and there are no extrema here. Symmetry. Symmetry is an odd function, which means it's symmetric across the origin, or the point 0, 0, right? If you notice that on the graph, it's a mirror image across the origin here. Asymptotes, we already mentioned there's one vertical asymptote, and the vertical asymptote is x equals 0, and there's one horizontal asymptote, and the horizontal asymptote is y equals 0. End behavior is a little bit tricky, so let's take a little more time to work on that, right? So here's what the basic graph looks like, right? Looks like this, like this. So we say the limit of 1 over x as x goes to minus infinity, and the limit as x goes to positive infinity of 1 over x. Let's look at that. As x goes to negative infinity, that's as it goes this direction, y comes closer and closer to 0. And this says as 1 over x, as x gets very large, so as you go in this direction, as x gets larger and larger and larger, what happens to y? Y is equal to 0. That's the graph and the properties of 1 over x.